Text-to-SQL fails before generation when the model sees the wrong schema. Retrieve the right tables with SentenceTransformers. Then make SQLGlot reject bad columns and joins. After this, you'll understand how to assemble a pipeline that links a question to the right schema and returns a validated query. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Schema overload is a common failure mode when you ask an LLM to write SQL. The model sees every table and column and then guesses. Those guesses often pick the wrong table or an ambiguous column name. The practical fix is twofold. First, retrieve only the small set of tables that match the user question. Second, validate the generated SQL against that slice, so you never execute a wrong reference. Here is the intuition. Turn each table and its columns into a compact text card. Embed those cards and embed the question. Find the nearest cards. Use that short list to build a slim prompt for the LLM. Then, after the LLM returns SQL, use SQLGlot to parse and qualify identifiers against the retrieved schema. This reduces hallucinated joins and unknown columns. We will build a tiny pipeline that does exactly that. It is small enough to run locally with toy metadata, but the pattern scales. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We start by turning a small toy schema into compact cards we can embed. This snippet produces compact text cards for each table, so the retriever only has to index manageable units instead of the whole catalog. The code stores the metadata in a schema dictionary, and cards converts each table into one retrievable unit containing the table name plus its columns. Sorting makes the order stable, which matters once retrieval scores are added later. The visible output confirms how many schema units are ready to embed. Picking candidates needs a semantic match step, so next we embed question and cards and score them. This example uses SentenceTransformers to compare the user question with each schema card and surface the best matches. Model encode document cards embeds the schema side. Model encode query question embeds the natural language side. And model.similarity query vec.docvex produces a score for every card, so you can rank candidates before asking the LLM to generate SQL. The model name is small enough for a local tutorial, while still exercising the real SentenceTransformers API. The visible output shows the best matching table and its score, which becomes the first retrieval signal. Now convert those similarity scores into the compact schema slice we will actually show the LLM. This snippet turns embedding scores into the small schema slice that goes into the text-to-SQL prompt, so the LLM only sees likely tables. Ranked keeps the highest scoring cards first. Picked extracts table names, and schema slice turns those names back into structured columns. Prompt schema is the compact payload you would pass to an LLM instead of the full catalog. Raising the slice size improves recall, but spends more context and may reintroduce distracting tables. The output shows which tables survived retrieval and how much text was removed. A draft SQL can still refer to ambiguous or missing columns, so we make identifier binding explicit with SQLGlot. This snippet uses SQLGlot to make identifier resolution explicit after a draft SQL query appears, so you can detect wrong table or ambiguous column references early. Parse 1 raw SQL builds the SQLGlot tree, and qualify schema, typed schema uses the retrieved schema to attach table context to column references. Then tree.findAll XP column lets the pipeline inspect what the query actually touches. The visible output shows SQLGlot found qualified column references, which is the basis for rejecting bad identifiers before execution. Finally, add a lightweight join and parsing check so we do not run incorrect cross-table queries. This example turns the pieces into a minimal text-to-SQL safety baseline that both narrows retrieval and verifies joins before execution. Retrieval narrowed the schema, and SQLGlot now verifies that the final SQL can be parsed and qualified against typed schema. The joins dictionary is a small allow list that represents known relationships, so the pipeline can reject a query that joins plausible tables on the wrong key. Checked is the qualified SQLGlot tree and used records which tables the query actually references. The output shows the validated table pair and join key, giving a compact end-to-end checkpoint before execution. In a real project, you would replace the tiny cards with metadata from your data catalog and use FAISS for fast nearest neighbor lookup over thousands of tables. The same qualify and check step runs unchanged against your production schema. What we built in 3 quick points. It links a natural language question to a small set of relevant tables before generation, so the model has far fewer choices. Use this when your catalog is large or when ambiguous column names cause frequent errors. One caveat is that overly aggressive retrieval can drop a needed table, so tune the slice size against your queries. To extend this exact approach, tune your vector index settings next. Build a FAISS index over cards and experiment with nlist and nprobe to trade recall and latency. Increasing nprobe raises recall for multi-table questions, but costs query time, which is the right lever for production QA. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.